Hello again. So this will be the continuation of our discussion in the connective tissue. And we have here the bone. So the bone is also similar to cartilage in which it is a special form of connective tissue and consists of cells, fibers, and extracellular matrix. So because of the minerals deposition in the matrix, bones become calcified. So the main function of our bone is supports the fleshy structures, it protects the vital organs, and harbors the bone marrow where blood cells are formed. It also serves as reservoir of calcium, phosphate, and other ions in the body. So now let's discuss the different cells that can be found in your bone. So the first one is osteogenic cells or osteoprogenitor cells that are located in the periosteum or endoosteum. So these are capable of being transformed into osteoblasts, which is bone forming cells, or osteoclasts, which is a bone destroying cells during the times of stress and healing. Then the second one, we have osteoblasts. Osteoblasts are on the bone surfaces and synthesize osteoid matrix. And it aids in bone resorption that needed enzyme secretion and parathyroid hormone influence. It also promotes bone growth. So the third bone that we have here is osteocytes. Osteocytes are mature osteoblasts that are branched and are located in a lacuna. And they use canaliculi for communication and exchange. These cells also maintain homeostasis of bone and blood, concentration of calcium and phosphates. So these osteocytes do not divide. They are not capable of osteolysis, and it also has a flat morphology and cellular processes. And the last cell is osteoclast, in which um, it has a striated border, which increases the surface area of osteoclast. It is the main function of this one is for bone resorption. So these are the different cells that can be found in your bone. And then the other component of your bone is your bone matrix, just like in your cartilage matrix. So the bone matrix is composed of a ground substance and a extracellular fibers. So the ground substance in the bone is composed of two inorganic substance and organic substance, wherein the inorganic substance, it is composed of calcium, phosphorus, bicarbonate, citrate, magnesium, potassium, and sodium. While the organic substance, it is composed of proteoglycan molecules and glycosaminoglycans. Um, the other component of the bone matrix is the extracellular fibers, which consists of only type 1 collagen fibers that is highly cross-linked. And those are the components of your bone. And your bone has two types. We have spongy bone and compact bone. Now, what is the difference between the two? Spongy bone is it houses the blood vessels. It is less dense, softer, and weaker. The ends of long bones and proximal to joints and within the interior of the vertebra in which this spongy bone is located. Hematopoiesis occurs in the bone marrow, and it contains trabeculae or spicules. These trabeculae are the functional unit of the spongy bone, and the spicules are the tiny lattice-shaped structures that form the tissues. So as you can see on this picture, um, we have the different parts of your spongy bone. We have the Haversian canal, we have the Volkmann canal, we have the periosteum, wherein the periosteum is the outer layer. Uh, it consists of the outer layer, which is fibrous, the inner layer that is osteogenic, and they also have the Sharpie's fibers. And canaliculi, the mode of communication of the bone cells. So next one is we have the compact bone. So compact bone are denser, harder, and stronger. So they form the cortex of most bones. So there are different parts of the compact bone. We have Haversian canal system, in which this is the functional unit of the compact bone. So in spongy bone, the functional unit is trabeculae, while in compact bone, the functional unit is Haversian, Haversian canal system. Okay. So the second part is circumferential laminae, in which it has an outer laminae and inner laminae. The outer is deep to periosteum, forming the outermost region. So it contains sharpest fibers. So the inner lamellae, it encircles the marrow cavity. So the next one is interstitial laminae, in which the laminae remaining from the osteon partially destroyed by osteoclasts during the growth and remodeling of the bone. Then the canaliculi. The canaliculi is the communication channel interconnecting the canals between the adjacent lacunae. Then we have the Volkmann canal. Okay, so uh, the spongy bone also has that one, but the difference is the functional unit of the two types of the bones, which is the um, tuberculate and the Haversian canal system. And we have two processes involved for bone formation. So we have in intermembranous ossification, the bone develops directly from osteoblasts that produce the osteoid matrix. So initially, the spongy bone, it consists of a trabeculae. And the mandible, the maxilloclavicle, and the flat skulls of the bones are formed by this process. And then the fontanelles of the newborn skull represent the areas where intramembranous ossification are occurring. So this how does this work? Well, what is the process on this one? So there are groups of mesenchymal cells, as you can see on this picture, number one. The groups of mesenchymal cells in the membrane or sheet of embryonic tissue round up and differentiate as osteoblasts, producing osteoid. So they're producing the extracellular matrix. And then next one is the cells are trapped in the calcifying matrix that differentiate as osteocytes. Then the third one is the woven bone is produced in this manner with vascularized internal spaces that will form the marrow cavity and surrounded on both sides by developing periosteum. Then the last one, remodeling of the woven bone produces the two layers of the compact lamellae bone with cancellous bone in between, which is the characteristic of a flat bone. So the next one is the endochondral ossification. So in endochondral ossification, uh, the endochondral ossification, the hyaline cartilage model calcifies and the cells will die. So the mesenchymal cells here in periosteum differentiate into osteoprogenital cells and form osteoblasts. Then the osteoblast will synthesize the osteoid matrix, which calcifies and traps the osteoblast in the lacunae as osteocytes. Then the osteocytes will now establish the cell-to-cell communication via canaliculi. So the primary ossification center forms in diaphysis, and secondary center of ossification is in epiphysis. So the epiphyseal plate between diaphysis and epiphysis allows for growth in bone length, and all cartilage is replaced except the articular cartilage. Okay. Now, what is now the process? So this is the process now. How does the uh, cartilage will turn into a bone? So the first one is a bone collar forms around the middle of the cartilage model and the generation of the underlying cartilage. And then the second one is that it followed by invasion of the resulting ossification center by capillaries and osteoprogenitor cells from the periosteum. Then the osteoid is deposited by the new osteoblast woven bone is calcified and compact bone is remodeled. And there are uh, then there will be um, and then a primary ossification center develops in the diaphysis along the middle of each developing bone. Then the secondary ossification centers develop somewhat later by a similar process in the epiphysis. So the primary and secondary ossification centers are separated by the epiphyseal plate, which provides for continued bone elongation. Bone elongation. So the two ossification centers do not merge until the epiphyseal plate disappears when full stature is achieved. So while you are growing, uh, this is the process of your bone growth. So it happens in your arms and in your legs, the legs, the thigh, and your feet. So endochondral process is involved in this one. And there are 5 zones of epiphyseal cartilage. So the first zone is zone of resting cartilage, in which there are no morphological changes here in the hyaline cartilage, and it is the farthest from primary marrow cavity. So the second zone is the zone of proliferating cartilage, in which rapid division of cartilage in the interstitial growth that forms in columns, and the chondrocytes are stuck and parallel to the bone axis. So the third zone is the zone of hypertrophic cartilage, in which the chondrocytes are enlarged and rounded due to the accumulation of glycogen uh, from the resorb matrix. Then the um, fourth zone is the zone of calcified cartilage, in which there is a calcification of the cells due to the deposition of the hydroxyapatite. And then the fifth zone is the zone of ossification, in which it is fully ossified bone. The endochondral tissue appears, and it appears the odontoblast. So those are the 5 zones of the epiphyseal plate. Now next, what if your bone will be damaged? So that is now the question. How does your bone will heal? So we have bone repair, just like in your cartilage. Your bone will also regenerate, but it will take time. It depends on how severe the damage is. Okay. So how does your bone repair? What is the process now of your bone repair? So the first one is the blood vessels that are torn within the fracture release blood, which clots to produce a large fracture hematoma. Then, this is gradually removed by macrophages and replaced by a soft fibrocartilage-like mass of procalcious tissue that is rich in collagen and fibroblasts. So if broken, the periosteum reestablishes continuity over this tissue. Then the soft procalus is invaded by regrowing blood vessels and osteoblasts. So in the next few weeks, the fibrocartilage is gradually replaced by trabeculae of primary bone, forming a hard callus throughout the original area of the fracture. Then lastly, the primary bone is then remodeled as a compact and cancellous bone in the continuity with the adjacent uninjured areas, and fully functional vasculature is established. So it will take time. So the process inside your bone is like this, but we have to cast it so that mm, it will not distort the area where the bone was damaged. And that ends our lecture for the bone. I'm hoping that you also learn something from this. Thank you and have a good day.